Hi, my name is Bill Malik. I'm the Vice President for Infrastructure Strategies at Trend Micro. And my topic in this session is the peril and promise of 5G. In the course of this material, we're going to begin by looking at what 5G actually is. It's not one thing. It's actually a series of capabilities released over 5 separate generations of specification. We're now in REL 14. REL 18 doesn't come out until probably the end of 2023. And that's when we'll finally have full 5G available to build. So to begin with what 5G is, we're going to take a look at these critical functions. First of all, it's going to be faster. In order to get faster, that means it's going to be using new technology, new sections of the radio frequency bandwidth, and it's going to rely significantly on virtualization, both for network and for application support. We'll go through these in more detail later. On this chart, we're seeing the stress between the three major capabilities of 5G. Enhanced mobile broadband, which means incredibly high capabilities for upload and download. Three-dimensional real-time video, smart home, smart building fall into that area. Down on the lower left, we look at massive machine type communications. This is supporting very large numbers of devices working in concert. The densities of devices they're talking about are on the order of 1 million per square kilometer. That means on average, a 5G enabled device every square meter across a congested area. We have tremendous demands on the network infrastructure and tremendous enhancements needed in 5G's networking technology to support it. And then on the lower right, we have ultra reliable, low latency communications, very high quality of service. Today, error rates are on the order of 1 out of every 100 blocks, and the solution is to retransmit. For ultra reliable communication, they're talking about error rates on the order of 1 every 100,000 blocks, all the way down to 1 error out of every billion blocks. This will require a tremendous amount of computational effort, which means we're going to need to use edge compute devices to support these. We will not have time to get to the cloud in the traditional internet sense at all. These things pull in different directions. Massive machine type communications combined with enhanced mobile broadband means you have a tremendous amount of traffic going through an area. It's easier to do one if you throttle back the other. Similarly, extremely high quality computational support means that you're going to have to spend an awful lot of energy at the edge devices in order to support what's going on, adding to the overhead for the enhanced mobile broadband world. Now, in terms of the time frame, 5G currently is based on Release 14. This is the third generation partnership program. It is a consortium of the major cellular technology providers in each region. So they collectively decide what the standards ought to be, and the way the process goes is the various phone companies, equipment manufacturers submit standard requests. The group behind each release decides what functions ought to be included in that release, and then they go about specifying those things to the level that they can then be manufactured. As I said, Release 14 is basically 4G LTE. Release 15 came out at the end of 2019, and that means we're going to see those functions built into handsets in this year. We're currently working on Release 16. That's coming out a little bit later this year, and we're getting into Release 17, which is going to come out at the end of 2021, early 2022. Now, here's the thing. Release 17, according to the gentleman running the program, is going to be a small release, 12 or 15 functions. He wants it to cycle through the system in a year and a half or less. But when we take a look at the features that are being bid for in Release 17, we've got close to 50 or 60 items on the wish list. Many of these, if you want to go through the details, will support new radio. They'll support quality of service. They'll support convergence of wireless and wireline. A lot of needed capabilities here, but these are candidates for Release 17. As I said, only about a dozen will make it. The way the 3GPP works is all of these functions that aren't included in Release 17 may be resubmitted for Release 18 after 17 gets underway. And that's going to be a big release. It's going to be 4 or 5 times larger than what's going to finish in the next year and a half. And that's why we say the target for this is going to be the end of 2023 or the start of 2024. That's when the manufacturers will have a solid set of standards to do what should be the final release of 5G, which will not be in consumers' hands until probably the end of 2023 or well into 2024. So it's spread over a long period of time. There's a lot of capabilities taking place over many, many years before we get to full 5G. Among other things, it'll require new antennas, it'll require new cell towers, it'll require new technology to handle the traffic at the cell base, and it'll require new antennas in the handsets themselves. The higher frequencies don't have the lovely properties of the radio that we now know. For instance, they don't go through walls. They're reflected and stopped by rain. They're blocked by growth of leaves. They don't go through windows. So you need many, many more antennas to broadcast the signal. And in the handset, you need a pair of antennas that are at right angles in order to receive the signal when you turn your head. Those of you who remember the very first generation of cellular phones will recall the problem where you'd have to move around in order to get the signal. Well, that's coming back with 5G new radio. So let's take a look at some of these vulnerabilities associated with these features. There are vulnerabilities in the physical and software infrastructure, and we're going to drill down in that software infrastructure into virtualization issues and into what I'm calling metadata pollution, which is actually a new version of a very, very old CompSci problem. So when you take a look at the network itself, this is a comparison of what it's going to take to go from 4G that we know today to the 5G new network technology. At first blush, you can see there is an incredible increase in complexity. Add to the fact that the range of the new 5G radio is going to be about 100 meters. So you'll need to have an antenna just about every other city block in order to maintain continuous service. Then on top of that additional hardware complexity, you have multiple layers of software giving you your network capabilities, your application capabilities, and the underlying 5G core set of functions. This will not be using a proprietary network. All this information is going to be hauled back over the conventional internet, opening telephony traffic to a new set of issues that we haven't faced before in telephone, except maybe for people doing IP telephony. This diagram is meant particularly to take a look at the layers of complexity on the back end, the right-hand side of the chart. I've already mentioned the need for additional antennas. These are all the kinds of attacks that can take place. Looking at the next to the rightmost piece of this diagram, what we see here are multiple layers of virtualization to provide the network, to provide the storage, to provide the application, and to provide the infrastructure to connect the application to that storage and to core telephonic services. The biggest vulnerability here actually isn't the fact that virtualization is problematic. Virtualization is pretty good. It's been around for a long time. I was there when it first showed up back in CP67 many years ago. The problem is the rate with which these virtual environments need to be stood up and torn down. As an individual walks around the corner, they fall out of range of one cell and need to be picked up by another. That entire stack of application, storage, network infrastructure will have to be torn down and rebuilt in the new tower. That means that as people move around, or as cars move around, or as capabilities in a warehouse or distribution center move from place to place, there will be a tremendous amount of activity tearing down and reestablishing these stacks of virtual environments. It's not the problem of can virtualization handle it? It's the problem of what is the metadata going to do when it gets exhausted? And that brings us to the next couple of charts that I want to go into. Here we have a list of the various security threats where they'll show up, what pieces of the 5G environment will be attacked. I'll leave it to you to review the references to find out the detailed information behind each of this. This is from a IEEE conference 3 years ago, by the way. So the first of the two problems associated with exhausting metadata has to do with rolling a counter. You may have heard of the problem in April of last year when GPS satellites rolled a counter. There was a 10-bit counter that was ticking off the weeks since January 1980. And if it's a 10-bit counter, that's 2 to the 10th is 1,024 after 1,024 weeks, or slightly less than 20 years. The counter rolled over. Not a big problem when it happened in 1999, but a bigger problem when it happened in April of last year. On the left-hand side here, we show a console from a Boeing 787, which was reporting to the pilot that today's date is August 22nd of 1999. Now, a defect like that renders the aircraft not airworthy. And in fact, there were about 14 or 15 new generation Boeing aircraft that were not able to fly until the satellite feed was corrected. On the right, we have a consequential effect from that. The New York City wireless internet network, NYC WIN, went off the air also on the 6th of April 2019, but didn't get back up for over a week because sorting out what had actually gone wrong and resetting the appropriate systems took that much effort. This had some inconvenience to visitors and residents. It disabled some functions that the New York City Police Department used to manage traffic. In the center, we have pictures of an HP solid-state drive and a Cisco router, both of which also have counter rollover type problems. In the case of the HP device, once it goes through 32,585 connections, it runs out of capacity, and all the data on the SSD is lost. 32,768 hours of operation. That's 3 years, 270 days. If you don't update the firmware, the device fails and the information is not recoverable. In the case of the Cisco, the issue there is the NAT pool converting. Again, it exhausts itself after running out of entries in the table. The problem ultimately comes down to what was called in the late 50s and early 60s garbage collection. You have a program, the program runs, it ends, but it doesn't free up all of its storage. And so there are pieces of storage that are allocated, but the owning system is not identifiable, so you can't get rid of it. This problem was described in the first part of 1960 in a paper by John McCarthy. And this diagram of metadata pollution is a way of looking at this. We've all experienced defragging our hard disks. On the bottom left and on the upper right, we see the processes from Windows 7 and before, going through your disk drive, consolidating empty space, moving programs to give you bigger blocks of empty space. On the bottom right is Marie Kondo's approach to simplify and organize. And in the center is the Swiss psychologist Jean Piaget. This is his office. It's kind of like my office. It looks comfortable, unless you are an organizational freak. The metadata pollution effort refers to the fact that as you take up and tear down these virtual images, we recover that space. But what we don't recover is the tag that says space was allocated at this time for this duration. Over time, as we stand up and tear down these virtual environments, these pools of available quantities that collectively make up the metadata to manage these virtual environments, those pools dry up. They run out. And once they run out, you can't build anymore. Now, I do not have a specific use case, but having been in IT for 46 years, I know that these are finite quantities, and some of them have been around a long time, and they're not 64-bit. If you stand up and tear down hundreds of thousands of virtual images every minute in a congested city center, as residents move about, you will exhaust various tables. And that's the metadata pollution problem. And that's the biggest issue I see as a potential failure in 5G going down the road. So let's take a look at what countermeasures you can adopt. There are three categories. There are technology measures you can take, there are regulatory measures that we'll take, and there are procedural measures. Let's take a look at the technology ones first. In order to manage the instantiation and recovery of multiple stacks of virtual images, again, the application, the infrastructure, the network, the storage, we need to rely heavily on orchestration. No human being will be able to type fast enough to set up the security context for a new application if that application only lives for 20 or 30 seconds as the individual running the app from his car turns a corner and heads down the road. User access must be validated. You got to know who's using the system. You've got to be able to authenticate them. You've got to make sure they're only using resources that are appropriate to what they need. And similarly, the devices that are providing information to the system also need to be verified. One of the attacks against cities, which I talk about in another presentation, has to do with spoofing GPS, with misdirecting traffic. It's especially bad when you talk about misdirecting ships carrying goods from port to port, congestion in ports, misdirecting ships to disadvantage them, to slow them down, to guide them into troubled waters. The network itself is going to have to become smarter. Now, self-defending networks are a fantasy, but we do know what needs to be done to strengthen and make such networks more robust. That needs to be put in place. We need to segment networks. We need to enforce multi-factor authentication among the administrators for networks and applications. The applications themselves, we need to do a better job of securing the application supply chain. When you look at the magnitude of apps that are available to 4G phone users today, with the additional capabilities of 5G, it's easy to see that number of applications skyrocketing, which means, again, no human being is going to be able to work quickly enough to verify the integrity of every new app as it rolls into every new system. And the speed with which these applications and any malware they might bring with them, either accidentally or intentionally, across 5G networks will be orders of magnitude faster, orders of magnitude worse than what we see with the propagation of bad information across 4G. The vulnerability of the software supply chain will now be highlighted. Because of the demands of extremely high quality environments, the need for exceptionally high quality of service, for exceptionally high and robust training, testing, and evaluating of the software development and deployment processes will again go very, very much higher than it has in the past. And finally, with virtualization and network infrastructure being virtualized, we see the need to improve orchestration, to simplify and lock down critical elements of these networks. Without that in place, 5G might fail to reach its promise, not because of any technical limitations, but because of procedural and, if you will, support type limitations. In terms of standards, regulations, and warranty, I expect to see regulations ensuring quality of service. That means if an organization says they are going to have an error rate of less than 1 per 100,000 blocks, and they fail to deliver that, that could have impact on the safety of transportation. It could have impact on the integrity of telemedicine. It could have impact on the integrity of banking and financial services. To simply seek a cash, a greenback poultice, if you will, money for the fact that you failed to meet the service as a provider, I think that's going to be inadequate. I expect to see serious regulatory challenges placed against organizations that do not deliver what they promise in the 5G world. The supply chain issue is a huge one currently. There are concerns that some vendors might not be on the up and up. We want to ensure the visibility of supply chain. We want to make sure that people can see where things have gone, especially those related to critical infrastructure. The big hack was the issue from about 3 years ago when a couple of reporters at Bloomberg News said that they'd found a grain of rice sized processor that was added on to certain components of many computer manufacturers' motherboards. Well, it turns out that that didn't really happen, but the level of concern that was raised by the possibility that it might have happened was huge. And we want to have the users, the consumers of the technology, have some visibility into the supply chain so they can go back and say, well, I heard that this and such is wrong, is not right. There's something wrong here. Can I check that out? It doesn't mean that the manufacturers have to disclose, critical intellectual property. It just means that we have to be able to trace back. And this is going to be related to issues such as right of repair that also are going to become more critical when you get into specialized applications. So where are we now with 5G? Well, we see it's going to roll out in phases over the next 5 years. It's going to require new infrastructure, software and hardware, new handsets, new ways of provisioning capabilities, heavy reliance on rapid virtualization with the associated problems with garbage collection and metadata pollution. 5G-based attacks will have greater scope of impact than attacks in older generations. Based on all of this complexity, it's our firm position that non-public networks, NPN, will in fact be more secure 5G environments rather than the big public, and the largest one, of course, would be a 5G-enabled smart city. We want to ask people to document, and once you've got the documentation, look at improving the ways in which you acquire, deploy, and maintain the hardware and software needed for your initiative around 5G. You're going to want to enhance whatever tracking you've got for software assets. Software asset management becomes crucial, not just for what you've bought, but for what you've built and for what you've rented. A third category of procurement that people don't think about much because it's so easy to just get a little bit of cloud for a temporary reason. We want to ask people to anticipate stronger regulations, stronger standards compliance, and stronger warranty provisionings. And we want to ask manufacturers to do more to verify the integrity of the components they're using, both any architectural limits, any metadata constraints, any interfaces, and how these things work under load and stress. If we are able to do that, then the future could be bright for 5G as it rolls out through the middle of this decade. That brings me to the end of my remarks. I'm offering here as part of the presentation a set of references used to develop this material. If you have any questions, please reach out to me through the local trend team. I'll be happy to provide answers as quickly as possible. Thanks for your time and attention. Enjoy the event. Have a good day.